All right, to introduce our discussion today, I want to throw a problem out at you. What if I wanted to add up the integers 1 through 10? 1 plus 2 plus 3 up to 10. Well, you could do that in a calculator pretty quickly. It'd come out to be 55, by the way. It wouldn't be too hard to do that, right? But what if our number set got bigger? Like, what if I wanted to go 1 to 100, for example? Well, the story goes, years ago, a young man named Carl Friedrich Gauss became a famous mathematician. His teacher, supposedly, when he's like 9 years old or something, asked his class to do that, thinking it would take quite a while. Well, he came up shortly and gave his teacher this answer, which was correct, by the way. How did he do that? This is kind of cool, okay? He basically thought of this thing like this. He didn't add them all up, by the way. Keep going. And then he reversed it. What if he started at the back of that number set? Well, he noticed a pattern. Mathematics is all about patterns. 1 plus 100, 101. 2 plus 99, 101. 3 plus 98, 101. So young Gauss recognized a pattern that to do 1 through 100, he didn't have to add all those up. He actually had 50 pairs of 101, which equaled 5,050. Ooh, that's pretty cool, okay? You could do that with other numbers. By the way, 55, what did I do? 1 plus 10 is 11. There's 5 pairs of 11. That's where I got 55 from. What if I wanted to add up the numbers 1 through 20? Well, there are 10 pairs of 21. Hey, you get 210. Look how quickly you can add up some number sets. So you can amaze your friends. Anyway, math's cool. Let's see how this relates to what we're doing today, okay? So we've been talking about sequences. We know what a sequence is, just some set of numbers, right? Well, if you add those up, you get what we call a series. Sequence and series sound about like the same thing, but mathematically a series is the sum of a sequence. Now here's a really cool formula from Gauss. I want you to think about it, and I'd write this down. This is only for arithmetic stuff, okay? So only if we're doing arithmetic. S sub n, so that S represents a series. N over 2, n is how many terms we have. You need the first term and the nth term. So again, think about that 1 through 100. Well, n was 100, right? 100 divided by 2. First term was 1, last term was 100. We had 100 divided by 2, 50 pairs of 101. Hey, that's where our 5,050 came from. Really cool relationship. Any arithmetic sequence, you could use this. So let's look at an example. What is the sum of the terms of this series? Well, think about what we need to know. Hey, there's my first term. Here's my nth term, right? Oh, but I don't know what term that is. I need to know what n is. So we're going to go back to this relationship from our previous lesson. Remember when we did arithmetic sequences? I need to know what term 36 is. Well, no problem. Let's plug stuff in. 36 is the first term plus n minus 1. I don't know what n is. That's what I'm trying to find out. Times d. Well, can you tell what d is? 4, 8, 12. Oh, I'm just adding 4 each time. So I'm going to do 4 there. Now I want to solve this equation for n. Let's subtract 4 over. So 32 equals n minus 1 times 4. Let's divide that 4 over. So 8 equals n minus 1. Add your 1. Hey, n equals 9. So n equals 9. Now I've got everything I need to use this relationship. So s sub 9 equals 9 over 2 times the first term plus the ninth term, which I already knew. I just didn't know which term it was. And so we have 9 halves times 40. Let's put that in a calculator. Let me bring my calculator up quick here. So we've got 9 halves. That's 4.5, by the way. You can just type 9 halves in. Times 40. And we get 180. So this adds up to 180. Ooh, that wasn't a very good 8 there. So 180. Pretty cool, okay? How about this? What is the sum of the last 5 terms of this series? Last 5. Well, in something like this, or what if they'd asked us the first 4 or whatever? In something like this, it might be easier just to list the numbers out. So last 5, well, what's going on here? 1 to 9, 9 to 17. Oh, that's going up by 8. So that means this would go down by 8. So 49, if I went down by 8, I'd get 41, right? And what if I went down again? 33, down again, we'd be what? 25, down again, I'd be 17. Oh, I'm down here, aren't I? 1, 2, 3, 4, 5. Okay. And so now, I just plug those numbers in my calculator, add it up. It's going to be just as quick to do that probably as go use a formula or anything. So sometimes you can just think your way through, just list problems out. Okay, let's talk summation or sigma notation. This is often used to represent a series. So here's kind of our general sigma notation. This just shows you the variable you're using. And this is our starting term, okay, the first value. So wherever we start, and up on top you got the last value, okay? And then here's our general formula. Here's a sigma. This is just a Greek letter sigma. When you see it, it represents summation. You're adding stuff up. So you've probably seen this before. I'd encourage you to write this down, label the parts. So for example, they say expand this. Well, this means you're going to do 5 terms, 1 through 5, and this is just the formula you plug in. So if I plug a 1 in right here, I would get 2 times 1, that's 2, minus 1, so that'd be 1, right? Now what if I plug a 2 in? 2 times 2, that's 4, minus 1 is 3. What if I plug a 3 in? 6 minus 1, 5. Can you see the pattern here? 4, 8 minus 1, so it's a 7. Of course 5, I'm going to get a 9. So this means this. Okay, it's just expanding. It's just a simple way to write a summation formula. And then of course you could just add all those up to get that if you needed to. But this just wanted us to expand it to recognize what it's doing. Okay, how about this? What if they ask us, excuse me, to represent, which expression represents the sum? So they're kind of going backwards. They give us this, they want to know, hey, which sigma notation would be this series right here? Well, the easiest thing to do, let's go find, these are all 1 through 6 by the way, so that matches. Which of these formulas, if I plug these numbers in, would give me these numbers? So I need to find one that starts with a 1. Well, if I put a 1 right here, that'd be 2 plus 1. That doesn't work. If I put a 1 right here, 1 minus 1, 0. That doesn't work. If I put a 1 right here, 2 minus 1, hey, that's 1. So that has promise. What if I put a 2 in? 4 minus 1, that's 3. Hey, that one's looking pretty good. How about down here if I put a 1? 1 plus 1's 2. Hey, that doesn't work. Hey, there's a winner. Okay? Now, last thing here I'd like you to look at. On the lesson, as you go through, they're going to give you some sigma notation stuff. Desmos calculator doesn't do it, at least that I'm aware of. But here's a website, and there's a bunch of them. Okay, if you go type summation notation calculator, sigma notation in Google, you find all kinds of calculators. Here's one I like though, and I've also linked it below this video. I'd encourage you to go check it out. It just helps and play with it a little. This is just a screenshot, but you can go plug stuff in, sigma notation, do a lot of calculations there relatively easily. Okay, so I hope this will help you get started in your lesson.